study the exchange of heat or energy from the system to the surrounding. And what is a system? System is a region of space, and the region may contain a collection of large number of atoms or molecules within a real or imaginary boundary. Within a real, so this boundary which separate system from surrounding, that may be real boundary or that may be virtual or imaginary boundary. So we are taking one example, the Earth atmosphere. So Earth atmosphere that behaves like a system of large number of gas molecules having finite boundaries, and beyond that boundary there is a huge space. So Earth atmosphere is getting the energy or heat or radiation from the space, from the sun, and some part of the energy or heat or radiation that is reflected back into the space from the Earth atmosphere. So there is an exchange of heat, energy or radiation in between space and Earth atmosphere. So Earth atmosphere is a thermodynamical system, right? So this is the first part of the thermodynamics, and we defined what is a thermodynamical system, what is surrounding, and what are the boundaries, right? So let us go for the surrounding. Surrounding, basically it is also the medium or matter that surround the system, which may participate in the process of exchange of matter or energy with the system. As I discussed earlier, that there is an exchange of heat, energy or radiation from the system to the surrounding, and from the surrounding also to the system. Boundary, already I discussed that it may be real or it may be imaginary. So this is a line which separates the system from the surrounding. Now the next topic is the thermodynamic state variables. Very important topic, thermodynamic state variables. Variables means the parameters which changes during the experiment, the parameters which changes during time. So these are called the variables, and here we have thermodynamic state variables. So what are thermodynamic state variables? So the parameters which determine the state or condition of a system are called thermodynamical state variables. So we are given some example: pressure, volume, temperature, internal energy. So they are called thermodynamical state variables. So let me explain it in more detail. So suppose we have a system. And in that system we have some gas. It is filled with a gas, and suppose the pressure of the gas is P1, volume of the gas is V1, temperature of the gas is T1, and internal energy of the gas is U1, right? So, and I call this is state of the system. Presently the system is in this state of the system. State of the system means presently what are the values of pressure, volume, temperature and internal energy. So that is called state of the system. So presently, right now, currently the gas system has pressure P1, volume V1, temperature T1 and internal energy U1. Now our system, from the present system, that goes to the next state, and in that state the gas attains pressure P2, volume V2, temperature T2 and internal energy U2. So you see the pressure is changed from P1 to P2, volume is changed from V1 to V2, and temperature is changed from T1 to T2, and internal energy is changed from U1 to U2. So that's because all these P, V, T and U, they are changing from one state to another state one state to another state. So that's why these parameters, these are called thermodynamic state variable. In one particular state, they have one set of values. In another particular states, they have another set of values. So because they are changing from one state to another state, and even they can go back to the original state. So that's why they are called thermodynamic state variables. They are called thermodynamic state variable. Is it clear? Thermodynamic state variables, because they can change their state. They can change their states. So that's why they are called thermodynamic state variables. So again, the thermodynamic state variables, they can be categorized in two categories: intensive variables and extensive variables. So basically, we are taking three thermodynamic state variables: pressure, volume, and temperature. Pressure, volume, and temperature. So out of these three state variables, we will classify which are intensive variables and which are extensive variables, and how we can define intensive and extensive variables. So let us go for that. So before extensive or intensive variables, in our slide, we are given type of system. Okay, so intensive variable and extensive variables, that they will be defined in later slide. In my slide, type of system is first given. So I will take type of system. So system can be categorized into three types: open system, closed system, and isolated system. So now we can see from the picture what is open system. Open system means there is exchange of energy and matter. Matter means mass. Matter means mass. So here energy and matter. Matter means mass. Matter means mass. Both are exchanged in between system and surrounding. So that is called the open system. For example, a cup of tea, a cup of tea kept on the table. So that is exchanging both energy, even the mass. Vapors, they are also going out. Vapors are also going to the surrounding. So heat and vapors. Vapor is a mass. Vapor is matter. It is the form of matter. So heat, energy, and vapors both are going to the surrounding. So that is called the open system. Now, what is a closed system? In the closed system, only the heat can be exchanged in between system and surrounding, but there is no exchange of mass or matter from the system to the surrounding, and vice versa. For example, if we place a plate on the cup of tea, if we place a plate on the cup of tea, then no vapors, no evaporation to the surrounding will be there. Only the heat will go to the surrounding. So that is called the closed system. A cup of tea having some plate over the cup of tea, so that becomes a closed system. Now, isolated system means there is neither any exchange of energy nor any exchange of mass between the system and the surrounding. So that is called the isolated system. For example, we have a well insulated kettle filled with milk, water, or tea. So already we know that in the kettle there is no exchange of heat and matter or mass in between system and surrounding. So that is called isolated system. So already we discussed open system. In open system, both energy and matter, they are exchanged from system to the surrounding and vice versa. A cup of coffee already we discussed. So this is the example of open system. You can see the vapors, they are coming out. Even along with that, heat is also coming out. In the closed system, only energy can be exchanged between the system and the surrounding, but there is no exchange of mass. So there is no exchange of mass. So cup of tea having something over the cup of tea, so that becomes a closed system. We kept a plate, even a pressure cooker with a closed lid, that is a closed system. So these are the examples of closed system. Only heat can exchange from system to the surrounding, but mass cannot be exchanged. And the isolated system, nothing is exchanged, nothing, no heat, no energy, and no mass, nothing. So isolated system, it is also called insulated system. Insulated, well insulated. Coffee in a closed, well insulated thermos flask. This is isolated system, a thermos flask, because it is well insulated. Now this is a system well insulated from the surrounding. So there is no exchange of heat and mass. Now we come to the intensive variables. What are intensive variables? Very, very important question. What are, because already in our second or third slide, we discussed about the thermodynamic variables, pressure, volume, and temperature. Now, we have another thermodynamic variable, it is called the density of the gas, because we are dealing with the gas in thermodynamics. So, temperature of the gas, pressure of the gas, and density of the gas. So, what are intensive variables? So, they are independent of amount of mass. They are independent of amount of mass. So they are called intensive variable, for example, temperature, pressure, and density. And what are extensive variables? They are dependent and vary directly with the mass. So they are called mass, volume, and energy. So let me take one example through which you will get more clear idea about the intensive variables and extensive variables. Suppose I have a container filled with a gas. This container is filled with a gas. And I take a small portion of this container. And in this small portion, the pressure of the gas is P, temperature of the gas is T, and density of the gas is rho. Pressure of the gas is P, temperature of the gas is T, and density of the gas is rho. And this is a small area. You can see this is a very small area. Small portion of this big container having pressure P, temperature T, and density rho. And the remaining part of the container, now I take this part of the container. So in this part of the container, again, if pressure is P, temperature is T, and density is rho, then it means pressure, temperature, and density, they becomes intensive variables, because you see in this small region the mass of the gas is small. Mass of the gas is small mass of the gas, but in this region there is a large mass of the gas. So by changing the mass means by changing the area, the volume occupied by the gas, कितनी गैस है यहाँ, if mass, by changing the mass, if temperature, pressure and density they are not changing, so it means they are called intensive variables. यहाँ पे कम गैस है, so कम गैस का मास है, यहाँ पे ज्यादा गैस है, so ज्यादा गैस का मास है. So by changing the mass, pressure, temperature and density they are not changing, so they are called intensive variables. ज्यादा मास यहाँ पे है गैस का, कम मास यहाँ पे, उसके बावजूद भी प्रेशर, टेम्परेचर, डेंसिटी सेम, so they are called intensive variables. Now what are extensive variables? What are extensive variables? Now again I take the same container filled with a gas, and if I take volume of the gas in this small segment as V, mass present here is M, and energy of the gas molecule, basically the internal energy, I will call U. Now I take this area, the big area, definitely here volume is more, you can take it V1, M1, U1, but here the volume is V2, mass is M2 and internal energy is U2. So U2 is greater than, V2 is greater than V1, M2 is greater than M1 and U2 is greater than, so volume, mass and internal energy, they changes by changing the size of the container. So by in different segments of the container, in small segment of the container, volume is small, mass is small, internal is small. But if we take the larger segment of the container of the gas, then it occupies a large volume, having the large mass, having the large internal energy. So these parameters which depends on size of the container, they are called extensive variables. So mass, volume and energy, they are called extensive variables, and temperature, pressure and density, they are called intensive variables, right? So let us do some questions. Students, try these questions. Dash are thermodynamic state variables. All, yes, all are, because pressure, it is a thermodynamic variable. It also changes from P1 to P2. Volume also changes from V1 to V2. Temperature also changes from T1 to T2. So the all are thermodynamic variables. So all, answer is all are thermodynamic variables. Intensive variables are independent of amount of mass. Already just a little moment before I explained you, intensive variables are independent of mass. Dash variables are directly with the mass. Extensive variables, of course, extensive variables are directly vary with the mass. So these are extensive variables. Okay, so that